Dr. Nuno Castro, representing LEAP and specifically talking about LHC projects. Nuno, can you hear us?
Yes, I can perfectly. And you?
Hear you, yes. So Nuno,
Okay.
you can start. So you have roughly 15 minutes. Thank you.
Okay, thank you very much. So if you could please, I will be talking about the Portuguese participation at CERN and in particular at the LHC. And here I will be talking essentially about Atlas and CMS. We also have a small group participating in S&D at LHC, but I won't be covering it for the sake of time. So, I would like to start by thanking Michele Gallinaro and also Patricia Conmoinho from the team leaders of the CMS and Atlas teams, Portuguese teams, respectively. And now, if you don't mind changing slide. Okay, so let me start by a bit of history. The Portuguese participation at the LHC was probably the first case where Portugal participated in a big international scientific collaboration from the very beginning, from the conception itself. So basically, these efforts were initiated even before the Atlas and CMS collaborations exist formally, and there are three names which are very important in this context: Gaspar Barreira, Amélia Maio, and João Varela. They were the initiators of this participation. I won't enter in much details, but I think it was important to make this piece of history. So if you could change the slide, please. Okay, so as you can see, the Portuguese teams were involved in both Atlas and CMS letters of intent from 92, and in both sides we had already a small team of people that in some cases in some cases they are still involved, but naturally now the team leaders and the teams have evolved, and they have younger people, and they grew significantly. So next slide, please. Basically, these are the teams now. So on the Atlas side, basically we have people from the three LEAP nodes, Lisbon, Coimbra, and Minho. So connected with the local universities, Técnico and Faculty of Sciences in Lisbon, University of Coimbra in Coimbra, and University of Minho. And LEAP basically aggregates the entire team. On the CMS side, the team is basically based at Lisbon, at the LEAP node in Lisbon, and some of the team members are also professors at IST, Instituto Superior Técnico in Lisbon. Next slide, please. Now starting with Atlas, the contributions to Atlas. Of course, I don't have time to cover everything, but I would like to highlight a few points. And generally, basically, we have contributed to the construction, maintained operations and upgrades of the detector, in particular with a very strong involvement since the very beginning in the tile-cal hadronic calorimeter, but also on the high-level triggers, and more recently, but already a long involvement on the Atlas Raman POTS detectors related to the forward proton tagging, luminosities, and so on. And since a couple of years ago, we also joined the high precision timing detector, the HPTD. Related, which is a detector for the upgrade for the ILUMI phase of the LHC. Physics side, we have been involved in a quite comprehensive set of measurements and searches, and if I can group them together, they basically correspond to precision measurements both on the Higgs and the top quark sector. Searches for new particles in interactions. We were quite involved in the search for new vector-like quarks, but also dark matter analysis, and more recently we have been exploring machine learning techniques related, for instance, to anomaly detection to make sure that we don't evade a possible discovery. And we also have a small group working in heavy ions collisions, in particular in jets as probes of the quark-gluon plasma. In terms of the performance activities, those are mostly related to tagging new heavy particles decaying into BB bars, again using machine learning, and also related to the hadronic calorimetry. So if you could change the slide, please. Yeah. In terms of the tile-cal operations, basically, if you look at the different aspects of data preparation performance, we are involved in most of them. So we are pretty much involved in the calibrations, in particular in the laser calibration system. We are involved in the databases and in the condition databases through the control, or the slow control, the DCS control of the detector, and in particular of tile-cal, and also pretty much engaged in data quality monitoring, again very much connected to tile-cal. Next slide, please. In terms of the forward detectors, we have the full responsibility of the DCS in Atlas. In IFP, the Atlas Forward Proton Detector, we have the co-coordination of DCS as well, and we are also quite involved in development, maintenance, and upgrades of the vacuum and the movement controls of IFP, and this is an area which is very important for the operation of the detector. Very important also in the computing, we are pretty much engaged in distributed computing on the Atlas side, and in particular coordinating the distributed data and distributed analysis through the participation, the Portuguese participation in the HL-LHC World Computing Grid. In particular, we have some important responsibilities in the computing run coordination and on the monitoring of sites and central services. And as we saw from the Brazilian colleagues, we also participate in the GLANCE system, this database, which is not only used by Atlas, but Atlas is the main client. We are also involved in the production management and integration, the software integration, and very important, the connection of these databases with the submissions of papers and coordinating all the continuous integration based on GitLab for the submissions of Atlas papers. Next slide, please. In terms of the trigger operations, I won't enter again in much details, but I would like to point out that in collaboration with some computer scientists at the Faculty of Sciences in Lisbon, we have been working in integrating GPUs, and this is full responsibility of the LEAP team, basically to accelerate the reconstruction of the topo clusters coming out of tile-cal, achieving a very significant improvement in execution time and integrating these in an harmonious way with the full event data model. We also have some coordination roles in terms of the high-level trigger performance groups, but yeah, you can ask me if you'd like to have any further details. Next slide, please. So, in terms of the upgrades, again, we are very much engaged in the tile cal, and in particular with the new high voltage distribution system, which will be easier to maintain and to repair, and requiring thinner and flexible long HV cables, which can be inserted through the movable chain. Next slide, please. Also related to the high voltage for tile cal, we have involved the Portuguese industry in supplying, testing, producing new boards, and supplying these to CERN. So it was also very important for the industrial engagement of Portugal. Next slide, please. This is a new effort, as I told you, our involvement in the high precision timing detector. We are contributing to the electronics again on the high voltage, benefiting from synergies with the efforts I just mentioned, but also in the front end chip performance, and the studies related to those and to radiation resistance. So the interlock of the luminosity and DCS is full LEAP responsibility, and also in terms of the DCS we have some responsibilities. You can see here some pictures, some real pictures from the interlock tests at CERN, and this is something we are quite proud of. Next slide, please. In terms of physics, I don't have time again for all the details, but I would like to flash you a few examples. So on the precision measurements, we have Higgs and TOPS measurements. So basically the measurement of TT bar associated to charm quarks, but also TTH, and exploring possible contributions of physics beyond the standard model to TTH, but also the WH associated production. We are involved in this channel since the very beginning, and the studies of spin and CP properties of WWH interaction, which also has important connections to the study of multi-Higgs production, which will be studied at the alumin phase. On the heavy ion side, we have been mostly involved in beep tagging development and calibration, achieving quite some impressive results for such an environment. And you can see the preliminary results which were obtained in terms of background rejection for light and heavy quarks. Next slide, please. In terms of the new physics searches, we have been involved in quite some different searches. The common aspect is to try to explore uncommon signatures and uncommon methods. As an example, I'm giving you an example of this of using the forward protons to be able to sensitive to new physics, which would be hard to access only using the Atlas main data. I would also like to highlight our leading role in the search for new heavy quarks, and we have been coordinating this effort for quite some time. In terms of techniques, I think we have been pioneering with other groups the use of anomaly detection to be able to increase the generality of our searches. Next slide, please. Now moving to CMS. Again, we are involved both in the detector construction, operation, calibration, but also on the physics analysis. I will discuss a few physics analyses without having time to make justice to all the efforts by the CMS team. I will focus on the main recent contributions to the detector itself, and also to the upgrades for the ILUMI phase. So next slide, please. To highlight a few examples, you can see here an important measurement of top quark decays in 2 tau leptons. This is a quite important measurement to test possible lepton flavor effects. A second example related to the precision measurement of multi-boson production, also related to heavy ions, the study of the properties of the KGP, and also a novel approach to use heavy flavor as a probe of QGP. And also exploring the synergies with the B physics, which the group is also involved in. The first observation of B short mesons in nuclear collisions. In terms of B physics, the group is rather involved in the search for new physics. These are typically indirect searches, but very powerful, and as everyone nowadays exploring flavor anomalies, this is a quite hot topic. And okay, next slide, please. I would like to detail a bit more, to give you 2 examples in more detail. One related to the exclusive production. So basically, it's a very cool idea of using LHC as a photon collider. If we can tag the protons, then when they radiate photons, then we can basically use a very tiny fraction of our data, which is basically a gamma collision data. These allow us to probe electroweak processes with very small cross sections, to study gamma interactions at high energy, and of course by measuring with detailed couplings, this can also be a rather important probe of new physics, because it can be sensitive to anomalous couplings, to new BSM resonances. Next slide, please. Here you can see a few examples using physics with forward protons. I mentioned this in the context of Atlas, but here it's the forward proton detector in CMS, which entered operation well before Atlas, and basically the LEAP team was involved in 4 important analyses. The first one related to the proton reconstruction, the second one exclusive top quark pairs, Z gamma plus X. This is a very important BSM probe, and also the exclusive WW and ZZ precision measurement. And again, by measuring precisely these couplings, you can be sensitive to BSM effects through the corrections of the couplings, which is also a quite interesting probe for BSM. Next slide, please. The second example I would like to mention is the double X production. Of course, this is extremely difficult. You can have it non-resonant or resonant. Of course, if in the non-resonant case you have different diagrams, you can have interference effects, and this is very important because the measurement of the X self-coupling is now one of the key measurements on the table. You have many BSM. Yes. Hello. Okay, I think it was. Okay, let me continue. So this is very important to measure the X self-coupling. Is very important to probe with precision the X mechanism and the electroweak symmetry breaking in the standard model, but in particular, because we don't know if we have anything beyond the standard model, which could be measured at colliders. And one quite promising example could be really this deviation in the self-coupling. So it's of course in the standard model this is extremely small, but if you have BSM effects, it can be significantly increased. Next slide, please. As I mentioned, the LEAP team, the Portuguese team, is involved in the detector upgrades of CMS for the ILUMI phase. So in particular in the calorimeter end cap, in the MIP timing detector. In the barrel calorimeters, and again in the precision proton spectrometer, the PPS detectors, because you have two of them. You have them in both sides, around 200 meters away from the detector. Next slide, please. So the LEAP team is really leading the efforts in PPS. PPS was approved for ILUMI for the ILUMI phase. But of course, the increase in pileup poses additional challenges, and this means that that precise timing is required. The LEAP team has a long expertise in ultra-fast electronics, and this is quite valuable here. So. The goal is to have a resolution of the order of 20 picoseconds per arm, which is rather challenging. Next slide, please. In terms of the MIP timing detector, basically the MTD is a thin layer between the tracker and the calorimeters, and the goal is to measure the time of charged particles with a huge time precision. The LEAP group involvement is related to the detector design, both on the construction and integration side, the electronics coordination in terms of the front end, the readout of the ASICs, and
I'm sorry to interrupt.
yeah.
May I ask you to finish in 2 minutes?
Yes, I will. No, don't worry. I'm about to finish. Also on the electronic side, and also in terms of probing the resilience to radiation. So next slide, please. Last but not the least, we have been contributing to the computing system of the LHC since the very beginning. So we operate a tier 2 center in Portugal. You can see the usage, the increasing usage over the last years of our tier 2, and in particular we have been contributing with a significant amount of computing time to our dimension, of course, and this is more or less evenly divided between CMS and Atlas jobs. Next slide, please. As I mentioned, I was close to finishing, so without too much modesty, I think we can say that the Portuguese participation at the LHC has been a success story, both in Atlas, CMS, but also very important in computing. Of course, the future started already, and we are working in the upgrade. We are quite engaged with the upgrades for ILUMI, and of course, it's not directly LHC, but after this phase, also thinking about contributions to future colliders. I think that's basically it from my side. So I'm at your. I'm available for questions, of course.
Thank you. Is there a question or comment to Nuno?
Hi, Nuno. It's Ulises here. Thanks very much for your participation. And I just want to make a quick comment that maybe not everybody knows, but there is an agreement of cooperation between Brazil and Portugal at the level of the Ministries of Science, which is followed by an agreement specifically between CBPF and LIP. And this agreement is for cooperation in particle physics and astroparticle physics. We have been using it a lot for astroparticle physics, but perhaps for particle physics, we could explore more. So one of the reasons of having our Portuguese colleagues talking in this meeting is to showcase possible avenues of cooperation. There is in particular a working group between Brazil and Portugal for this bilateral cooperation, which from the side of Portugal has Mário Pimenta in the group, and head Francisco Santos, which was the vice president of FCT, which is now in a morphing state. And in Brazil, it was myself and Galvão, which is also going somewhere else. So this group is evolving, but it exists. And it's an instrument for bilateral cooperation that we can explore to do things, even planning for joint funding actions between FCT and CNPq, which is something that we have been discussing a lot. So just to give some context of the relevance of what we have heard from Nuno. Thanks.
Thank you very much, Ulisses. Just to mention that it should be evident for everyone the connection. So from we just heard from the Brazilian colleagues in Atlas and CMS, but also from the Chilean colleagues, there are many possible points of connection. So there are a few where we do have collaborations, but there are definitely much more which we could have collaborations. So hopefully this will also help to trigger this, as Ulisses mentioned.
And we do have lots of projects in which we collaborate very closely.
Yeah.
I can mention again the PPS collaboration, which has been going on for 15 years or so, both in instrumentation and physics.
On the Atlas side, I mentioned this collaboration, which is also on alongside from in Glance, and I'm sure that we have more, and we can have even more. I'm pretty sure.
Certainly. Thanks a lot, Nuno.